Okay, hi everyone. Welcome to day 2 of Data Reuse Days 2025. My name is Alan Ang, Senior Partner Manager for Wikidata at Wikimedia Deutschland. I'm mainly responsible for data partnership projects with institutions globally. Feel free to reach out to me later on if your institution wishes to learn more about either Wikidata or Wikibase. In the next 2 hours, we are going to have 2 exciting sessions with my colleagues Lydia and Ifra to kick us off. Without much further ado, let me hand the floor over to my colleagues. Lydia, please.
Thank you so much, Al. Yeah, we will start with a very basic introduction to how to use Wikidata's data. And let me share my screen so you can actually see my slides. All right, so we will start with some basics about Wikidata to get everyone on the same page. So what is Wikidata? Wikidata is a knowledge graph. It's a sister project of Wikipedia. It's just like Wikipedia, a collaborative project, and all of its data is available under CC0, meaning you can pretty much do whatever you want with the data. Now, there are many knowledge graphs out there. What makes Wikidata a bit special in the eyes of someone who wants to use the data from Wikidata? First of all, you can be a part of it. If there's data missing in Wikidata or wrong, or otherwise you want to change something, you can do that. You can go and edit Wikidata and adjust the data in it and contribute to building it out. Also, Wikidata is trying to model the world in a bit of a more nuanced way than usual knowledge graphs do that. And it's very much centered around verifiability, meaning we try to find references for the data and attach them so you know where the data in Wikidata is actually coming from and can trace it back. Wikidata also, unlike some other knowledge graphs, has a rather loosely enforced ontology. So it is not very strict in how data is modeled, which allows for a lot of good nuance in the data, but also sometimes makes it a bit harder to reuse the data. Wikidata's data is also highly multilingual, so you can use Wikidata's data in pretty much whatever language you want, and everyone edits on the same data. Unlike, for example, Wikipedia, where each language version of Wikipedia is separate. On Wikidata, everyone edits and uses the same data and can display it in their language and edit it in their language. And a final point I want to highlight, what that makes Wikidata special, is that it is highly connected to Wikipedia, all of the other Wikimedia projects like Wikivoyage, Wikimedia Commons, and so on, but also over 9,000 other catalogs, websites, social networks, archives, you name it, on the internet that gives you access to a ton more data than Wikidata has alone. So very basic, what does the data in Wikidata look like? It is centered around items. Here you have an example for Maya Angelou that holds the data about Maya Angelou. It has a unique identifier that always starts with Q and then a number. And then further down, you have labels, descriptions, and aliases that give you, in your language, a name for the subject this entity is about, a description, a very short disaggregation description, and some other names that you might find the subject under. Then, as you scroll further, you have the statements, the actual data, if you want. That, for example, here says stuff like Maya Angelou is an instance of human, and all of that together makes up a statement. But statements on Wikidata can be a bit more nuanced, as I was saying earlier. You cannot just have a property and a value, like an award received, National Women's Hall of Fame, which Maya Angelou received, but you can qualify the statement to give it a bit more context, more nuance, say when it was valid, and so on. So in this case, there's a qualifier to indicate that she received this award in 1998. And you can provide a reference to verify where people can verify that claim. Now, if you do this for many subjects, then you end up with something like this, where you have a knowledge graph. And for Wikidata, you have a very big knowledge graph. So here, for example, you have Maya Angelou linked to her place of birth, St. Louis. And then, of course, you can continue to make statements about St. Louis, who the mayor is, and so on. Now, right now, this actually needs updating. Wikidata has about 115 million items. So 115 million subjects that we talk about in Wikidata, and we have data for that you can use to build your application. And about 12,000 properties. Many of those are there to link you to more data sources, as I was saying earlier, social networks, archives, libraries, and so on. And all of that right now makes up 1.66 billion statements that you can use to your heart's content to build something cool. Next to these items, we also have lexemes, which, unlike items, describe words, basically, words in your language. So you can build stuff like a dictionary. And all of that data doesn't maintain itself. No, it is maintained by a very lovely and active community of more than 13,000 active editors that edit on Wikidata every month to make that data available to you to build applications. Now, with all of that data, what do people and organizations actually build with it? There are a ton of applications and services out there built with Wikidata's data already. For example, by the OCCRP, the Organized Crime and Corruption Reporting Project, that uses Wikidata to support their work around fighting organized crime and corruption. Or the art browser, which gives you a very nice educational experience to browse art across different centuries, different museums, and more. Now I want to dive a bit into the different types of uses of Wikidata that we're seeing to maybe give you a bit of inspiration. So we have stuff like accessing the data in Wikidata to either use it directly or to augment data you already have. Some basic data. So one example for that is KD Itinerary, a travel companion that will show up in one of the showcases you should totally attend later in the data reuse days. People also use the data to train machine learning systems. I thought this was a really, really cool use case of Wikidata's data here, where researchers build a system to recognize the subject of old historic theater photographs. And then that system wasn't quite working in the way they expected it. It didn't always detect the right image or the right subject on the image. And it would detect stuff like a laptop. Very unlikely in a historic theater photograph from 1900 something, early 1900s. Now, what they did was run their system and then check against Wikidata, did this thing already exist that I detected in this image at that time or not, and if not, then try again. People also use the data to explore and visualize data or different topics. So one example here is the Open Art browser, which I already mentioned, but there's also research, for example, looking into political elite networks, so understanding how the different elites in a country, political, religious, and so on, are interconnected, and how, for example, specific families might be a bit too deeply involved in all parts of that matter in a country. So that's type of stuff is really helpful for us to understand, okay, how do these different things connect, get a bigger picture of things. Then people are using Wikidata as a gateway to the linked open data web. So to find more data that's not in Wikidata maybe, but that's in other places where Wikidata is their jumping off point. So for example, for a famous actor, you might have their Wikidata item, and then can from there easily jump to their Internet Movie Database ID and look at data there in addition to what Wikidata has. And then people use Wikidata as a source of notable entities for disambiguating, cataloging, tagging, and so on. So here I was talking about earlier, the Organized Crime and Corruption Reporting Project uses Wikidata's data to basically find different names for the people that they are interested in reporting on, so they can't hide under a different name and vanish easily that way. And last but not least, one of the things I wanted to highlight that people do with Wikidata is internationalization. For example, Mapbox provides maps, and you can internationalize the map with the data that Wikidata has, how different cities, countries, and so on are called in different languages based on what Wikidata provides. Because Wikidata has the names of these cities, countries, and so on in the different languages. Now, all of this is great, but how do you actually get to the data that Wikidata has? There are several ways, and some of them are better for some use cases than others, and I will give you some tips about what's there and when to use what. So here's an overview of the main ways we provide to access Wikidata's data, so APIs and similar. And I will go through each of them in a second. For all of these, there are a few network best practices that are important to keep in mind. So if you're accessing data from any Wikimedia project, including Wikidata, it is always good to follow the user agent policy. So do provide a meaningful user agent. So in case you're doing something wrong or harmful or similar, we can easily identify and reach out to you. Similar, there's a robot policy. Please follow it. Basically, don't make too many requests in too short a time. Yeah. And if you get, for example, a 429 too many request response, please listen to that and stop sending requests for a bit and then try again. Now, about the individual APIs and access methods. Let's start with the Wikidata query service. The Wikidata query service is a Spotlight endpoint. That means it is there to let you query all of the connections that are in Wikidata as a knowledge graph. It is currently backed by a software called BlazeGraph, and you can access its UI at query.wikidata.org. And you can access it as an API at query.wikidata.org/Sparkle. Some useful things to know about this. One is you can write federated Sparkle query on this Sparkle endpoint, but only to a limited subset. And query.wikidata.org lists which ones. And basically, it allows you to combine data from Wikidata and these other Sparkle endpoints into one query result, which can sometimes be very helpful. The official endpoint at query.wikidata.org is, of course, not the only one. There are some other endpoints out there that you can use, not officially run by Wikimedia. And if you have the resources and inclination, you can also run your own instance to work around timeouts and other limitations that you might have for your application. The query service UI also offers you the ability to embed the query results in a website live, which allows you to very easily and quickly build a prototype, for example. And the query service UI also gives you short snippets for your query in various programming languages, so you can easily embed it in your application. Now, you should use the Wikidata query service when you don't know the specific entities that you're interested in, but you kind of know their characteristics. So let's say you're interested in mountains that have a specific height and stuff like that. That's the type of thing that the query service can help you with. You don't want to use it if you're searching for text most of the time, or fuzzy searches. So for example, you don't want to use the query service to search for something that's called Mount Everest. And you also don't want to use it if you have millions of users. At that point, you probably want to run your own query service to not basically abuse the publicly available infrastructure that Wikimedia provides for everyone. And you also probably shouldn't use the query service if you expect your query results to be a significant part of all the data in Wikidata, of all the entities in Wikidata. At that point, you probably want to look at the nubs. For the query service, the robot and user agent policies that I mentioned earlier apply. There is a timeout of 60 seconds for your query. And if you run into that timeout, you can work, for example, with the community. There is a page on Wikidata called Wikidata:/request a query, where you can ask people for help with optimizing your query, for example. And sometimes there's stuff that can be tweaked to make it faster. And also, if you want a faster timeout, you can add a timeout parameter to make a timeout faster. For example, if for your application you need a very fast response, and if it would take longer, then it wouldn't matter. That's how you can do that. Now, one example of use of the Wikidata query service is Scholia, which is a nice front end to all the scholarly articles that are in Wikidata. That brings us to the second way to access Wikidata's data, which is linked data fragments. That you can find at query.wikidata.org/bigdata/LDF. And that is similar to the query service, but very, very experimental. And it uses more of your local computing resources instead of the public server-side resources. You can use that if you're looking for a list of entities based on simple triple patterns. You probably want to use it more if your result set is going to be larger. and if you're okay with doing a computation on your side instead of server side. And you don't want to use it if you need something very stable because it's experimental, and if you need a complete result set because it doesn't always give you the full result for your query. That brings us to access method number 3, the linked data interface. For every item on Wikidata or every entity on Wikidata, you can find this linked data interface at wikidata.org/entity/ for example, Q42, which then redirects you to wikidata.org/special:entity data/Q42. And there you can get data in different formats, from JSON to RDF to Turtle to NT to JSON LD. And depending on what you want for your application, you can choose. The linked data interface does content negotiation. So depending on what type of content of a format you request, it will give you that back. Or you can specify the format you want by appending its extension to the URL. So you, for example, going to wikidata.org/entity/Q42/RDF to get the RDF representation of Q42. You can also get specific older versions of the article or of the data by appending (revision equals) and whatever previous revision you would like the data for. And if you want a less verbose version of the output, then you can add (flavor equals) dump. Now, when do you want to use the linked data interface? If you're interested in a small-ish set of entities, especially in RDF, you want to use it if you already know the IDs for the entities that you're interested in. So if you already know that you want data about Douglas Adams and you know that Douglas Adams is Q42, then that's for you. And if you want the whole entity. You don't want to use it if you don't already know which entities you want or their IDs. Then you need to query or search first to find the entities. And you might not want to use it if you need a very large amount of data. Also here, the robot and user agent policy applies. And a trick, there are some cached URLs for specific formats and revisions. So if you need faster access, then use one of those URLs. And if you don't add a revision parameter, it will always give you the latest data, but it might take a tiny bit of additional time. Who uses the linked data interface? For example, OpenAlex, which is a catalog for scholarly papers, authors, institutions, and so on. Worth checking out as well. That brings us to the next way to access Wikidata's data, which is search. So you can find it on Wikidata at !search. And of course, there's also an API at wikidata.org/w/API PHP !action equals query and list equals search. You want to use that if you have a text string and want to find the entity that matches. So if you have Douglas Adams and want to get to Q42, then this is your way to do that. There are ways to make this search more powerful. So you can use some relations in the data as well to limit your search. For example, you can use magic words like has WB statement to limit it, to limit your search. So you can say, for example, has W statement P31Q5, to limit your search to only items that have an instance of human statement. Or you can use has description, has label, and so on to limit it to entities that have a label or description in a specific language or any at all, and stuff like that. You don't want to use the search if you need the relatively complex relations in the data, the connections in the graph, because the search is not powerful enough for that. Then you want to move to a query. And then we move on to the Action API. The Action API is MediaWiki's built-in API, so to say. It has existed for a very long time, and we have added Wikidata-specific pieces to this API. You can access it, including documentation, at wikidata.org/w/api.php. And on special API sandbox on Wikidata, you can even try it out interactively. Now, when do you want to use the Action API? The Action API you want to use if you, for example, as part of everything you're doing, you want to edit Wikidata. So contributing data and so on, that is, for example, done via the Action API. You also want to use it if you need JSON representation of data of a batch of entities, because you can request up to 50 entities in one request, or the JSON data for up to 50 entities in one request. When do you not want to use it? If you want a lot of entities, a large percentage of all entities that Wikidata has, then again, you want to use the dumps. If you just want to get the current state or the current data from an entity in JSON, then you might want to use the linked data interface instead, because that response is likely going to be a bit faster since it's cached. Useful stuff to know. You can filter in the API to get only some of the data from an entity. So for example, labels, descriptions, the claims, so statements, if you don't want the whole entity. Maybe also interesting to know, the Action API is what the Wikidata UI uses for doing all of its editing. So it's pretty deeply integrated in the software. And you can also retrieve entities based on a combination of client wikis. So for example, you don't know that Q64 is Berlin, but you know that you want data that corresponds to the English Wikipedia article called Berlin. Then you can also use that to identify the item you want to get the data from. Also for the Action API, the robot and user agent policies apply. In addition, it has a max lag parameter, which helps you figure out how overloaded the server is and if you're doing something too fast. For example, if you're editing too fast, then that helps you. And there are a few more recommendations on the API etiquette page to give you more information about good usage of that API. The Action API is, for example, used by Monumental, which is a tool to visualize data that different Wikimedia projects have about monuments, for example, collected at campaigns like Wiki Loves Monuments. And we'll show you images from Commons, articles, content from Wikipedia, and so on, all via access to Wikidata. And that brings us to the REST API, which is the newest kid on the block. which is a RESTful way to, or a RESTful API that allows you basic access and editing to Wikidata's data. Useful to know here, it's the newest one. It is now in its first stable version, but we're continuing to build it out. And there's a dedicated session for it later in the data reuse days. Right now, it supports items and properties. It doesn't yet support lexemes and entity schemas as other important parts of the data on Wikidata, but for most of the applications you're likely to build for now, you will need items and properties, so you should be fine. Just like the Action API, you want to use this when you want to access the current data of a Wikidata item or property, and if you need to edit items and properties. You don't want to use it if you want, again, a large section of entities, use the dumps instead, or if you want to edit lexemes and entity schemas, because it doesn't do that yet. So, that brings us to dumps. At dumps.wikimedia.org, we offer a way to download all the data that is in Wikidata or any of the other Wikimedia projects. There are different formats of the dumps for Wikidata available, specifically JSON, an RDF dump in different flavors, and an XML dump. There are truthy dumps you will find there. Those are the dumps that contain only the best ranked statements. So, for example, it will not contain historic data or references and qualifiers. So it's the smaller and less nuanced version of the data. But you can also get all of it, but then don't use the truthy dump. On dumps.wikimedia.org, you will find dumps for the last 3 months. After that, you will find them, for example, at the Internet Archive and via torrents. You want to use the dump if you need a significant proportion of all the entities on Wikidata, if you want to do large-scale analysis, for example. You also need it if you want to set up your own query service to basically bootstrap it. You don't want to use it if you are severely restricted in either bandwidth, storage space, or processing power, because they are fairly large and it will take you a lot of space and processing powers to unpack them and work with them. And you also don't want to use them if you need very current data, because they are snapshots in time, either every week or every 2 weeks. In general, recommendation is that you do not use the XML version of the dumps, because that contains the internal the dumps are, for example, used by Wikitrivia, which is a great game, which you should totally join us in playing during the social time later in the data reuse days. And that brings me to the last way to access Wikidata's data, which are the recent changes streams. They are at stream.wikimedia.org, and they're basically fire hoses of every change that's happening on all the Wikimedia wikis. And you can limit that to Wikidata changes only if you're only interested in that. You want to use the recent changes streams if you're interested in real-time updates. So if you're building a system that needs to be updated with every edit on Wikidata and you want to keep up with it, that's what you want to use. And this is, for example, important if you're running your own query service and you want to keep that up to date with what's happening on Wikidata. And a beautiful use of the recent changes stream is called Listen to Wikipedia. Recommend you try it out, which is a website where you can listen to edits as they happen on all the Wikimedia project, and you can change it to display the edits on Wikidata, and you can listen. It's a nice soundscape, and you can see the differences between, for example, a small Wikipedia and Wikidata, or a large Wikipedia and Wikidata, and how many edits, how quickly are happening there. Highly recommend it. Now, we went through all the different ways you can get to the data, and there are a few useful tools that help you along the way that you should know about. Number one are the constraint checks. So constraints are a way to define how a property on Wikidata should be used. So for example, that capital should be used on a country or something similar and not on a human. And if you look at an item, you can see if there is a statement that has an issue and violates some of those constraints, then we'll get a little icon next to it, and you can see that something is wrong with the statement and fix it. There's a tool called Constraints Violation Checker, which also lets you define a list of items you're interested in, and then on the command line, check them for constraints violations. So that is a nice way for you to keep an eye on data that is really important for your tool in particular, if there are constraints violations on them. Another way to do something similar are entity schemas, which define how certain classes on Wikidata should be modeled. And we're building that out now to be more integrated in Wikidata, but you can use that to automatically check items against their corresponding entity schema and see if there are any issues with the data that you're interested in particular. If you, for your tool, need a Sparkle query and don't want to write your own Sparkle, don't want to learn Sparkle, then you can see if the query builder, which is a simplified way to put together a Sparkle query in a GUI, if that is powerful enough to create your query. It is not exposing the full power of Sparkle, but it can give you a start to write the query you need. Another thing that's potentially interesting for you if you're trying to explore the data before you're building your application is the Wikidata Graph Builder. That can help you visualize relations around a particular topic you're interested in and see how the different classes in that area are connected, so you get a better understanding of what is there. Also helpful is a tool called Mix and Match, which lets you connect a catalog, an external catalog, to Wikidata. So here on the screenshot, for example, it's Netflix. So you have a particular Netflix ID, and this tool makes it easy for you to find the corresponding item on Wikidata, and then for you adds its Netflix ID in the background. So that's a good way for you if you want to connect some existing data that you have to Wikidata, then that is a good way to help you make those connections. If you, as part of your work, want to contribute data to Wikidata, my recommendation is that you start making some edits by hand And as you get more familiar and more experienced, you can switch to more powerful tools that allow you to do mass editing and be a bit quicker and so on. So once you have gained some experience, you can use a tool like quick statements to make batches of edits on a larger scale. Another thing, if as part of your work of building an application and looking at the data, you build out processes, for example, to find issues in the data, then a tool like the Mismatch Finder is there to help you contribute that back. If you aren't able to go through all of the issues you find yourself, then the Mismatch Finder is a way to enable the community to have a look at the issues you found and help you sort them out. And another thing that is probably helpful if you want to work with dumps are existing toolkits. I want to highlight two specifically. One is the Wikidata toolkit, and the other is the Knowledge Graph toolkit, KGTK. Both of those make it easier for you to work with the dumps because they have some built-in functions and so on to make that easier. All right, that brings us to some tips and best practices. Really important to understand if you are using data from Wikidata in your application, then you are part of the people who have a role in making sure that Wikidata as a commons stays around for a long time. We all have a role to play in that, and it's important for you as a builder of an application because you get better data for your application or service. You're doing a service to your users because they are getting better data that they're exposed to. You're protecting your reputation, and ultimately you're ensuring that Wikidata stays around for a long time and can sustain itself. And also, ultimately, it's just the right thing to do. So I would encourage you to give something back. And what that something is depends really on your specific case, but it can be stuff like attention and publicity. Talk about you using Wikidata and how it helps you create a great application. Give back data improvements. Like if you have some internal processes that find issues, give that back. Chip in with some maintenance work. Keep an eye on changes that are important to the data that you care about for your application, and reward mistakes and stuff like that. Give back expertise. Support the community in a specific topic that you know much about and where you can help build out Wikidata and make it better. For the development team, feedback and so on about what is working and what is not working well is really important. And last but not least, money and support for the development and programmatic work also always helps. And those are just some things to get you thinking. But I think it's important for you to think about what that small something could be that you can give back with your application. One way to do that is, for example, to indicate where the data is coming from in your application. So that gives your users the understanding of where the data is coming from and empowers them to also go back to Wikidata and fix it if they see any mistakes. How you do that is up to you. But for example, we have these powered by Wikidata icons that you're free to use as one inspiration if you would like to. Now, interacting on Wikidata itself, it would be really cool if you introduce yourself and what you're doing on your user page, for example. If what you're doing on Wikidata is paid, so if you're doing paid editing on Wikidata, then you are required to disclose that by the terms of use of the Wikimedia Foundation projects. But also it's in general good to let people know why you're there, what you're doing, so they can support you in the right way. And in general, be honest and upfront about why you are on Wikidata and what your motives are. Another thing I would recommend to you is to check out some relevant wiki projects. There are a ton of wiki projects, from music to medicine to Star Trek to video games to books. Whatever you can think of, there's probably a wiki project where all the people who care about that particular topic come together. So join them, see what's going on there. That will help you build a better application because you understand how the data comes to be and the decisions that are made around that. There are ways how you can keep an eye on changes that are relevant to your data. Here there are 4 listed: your watch list, Spark RC, Listeria, and Integrality that you can check out and help you keep an eye on changes that influence your application. And of course, you can build your own internal change tracking system if you feel like that is suitable for you. Then, I mentioned this a few times already, do let us know about any errors you find, right? Like, support the community in fixing issues. If it's on a small scale, bring it up on the project chat, for example, or in the wiki project. If it's larger, think about publishing reports that you let the community know about, or make use of the mismatch finder. Or even better, fix the issues upstream in Wikidata right away. You are welcome to edit. And if you're unsure about something, discuss it on the property talk page, on the appropriate wiki project, or on the project chat. Now, how do you get help if you get stuck? How do you stay up to date on all things Wikidata? There is documentation and support specifically for application developers at Wikidata:4developers, which has documentation, a support page, and more. If you need help writing a Spark query, that is available at Wikidata:request-a-query. And there's some general help on the Wikidata mailing list, on the project chat, or on the Wikidata Telegram chat. To stay up to date, you can subscribe to the weekly summary, which is a weekly newsletter about everything going on in Wikidata. Or you can follow us on social media, for example, on Mastodon at Wikidata at wikis.world. And with that, thank you so much. And we might have some time for questions. Emma.
Yes, woo, thank you, Lydia, for the wonderful presentations. It's very informative. Let's open the floor up to everyone for questions. I think we have about 5 minutes for questions. If you are unable to ask your questions in time for this session, don't worry. You can feel free to write an email to Lydia or write to me. I'll put my email in the chat later on. And if it comes to you, and then we will respond to you. Yeah, any questions? So I've been silently counting, a few seconds. If there's no question, actually, I've got one small question for Lydia. Okay, wait. Anybody has a question? No? Okay. I've got one small question. Lydia, in my interactions with different institutions globally, I came across some questions regarding, when an under-resourced small or medium-sized institution that wishes to reuse or access Wikidata's data for their community project. Among the various ways that you have proposed, what will be your recommendation for an easier approach? But hang on, I think we have a question in the chat that we can address first from the audience by Exod. Let me read out the question. I want to ask a question about constraints. Many times we see that the item is not mistaken, but the mistake is in the constraints. I feel weird changing the constraints, so I generally don't. What advice do you have about this, Lydia?
Yes. so this does happen if the constraint is a bit too constraining. And I would encourage you to bring it up on the talk page of the property and see what other people think if the constraint should be changed, because that's the place where that decision should ultimately happen. Just write a small message on the talk page, and maybe someone else has already brought it up, and you can just support their point even. But yeah, I would encourage you to bring it up so it can at least be discussed.
Thank you, Lydia. Anyone else has any question? We have about 4 more minutes. I know it's formulating your question. Don't be shy. Otherwise, yeah. So, Lydia, do you have any recommendation for an easy approach for a small institution to access Wikidata's data?
Yeah, I think the query service embedding it is definitely an easy way to build something quickly and prototypey. We will hear more about a magical tool called Snowman in the next session, which might also be very helpful in such a case. But if you're a small institution that does something worthwhile, also don't be shy to reach out to the team at Wikimedia Deutschland and the community in general. There are a lot of people who might be willing and able to support you.
Thank you. Thank you, Lydia. With that, I think there's no further questions. Then thank you, Lydia, for your wonderful session once again. And next up, we will take a 5 minutes break before our next session by speaker user ABB98 entitled Snowman plus Wikidata website from scratch. Please stay tuned. See you all in 5 minutes time.
Thank you, everyone.
Hello, everyone. Welcome back. I just want to share with my colleagues that we can start the live streaming to YouTube and also begin the video recording. Hi, everyone. Welcome back to the second session of day 2 of Data Reuse Days 2025. Next up, we have a next presenter, user ABB98 or Elvin, to share with us about a wonderful project, Snowman, and the session is entitled Snowman plus Wikidata, website from scratch. Alvin, if you are here, the floor is yours.
Thank you very much, Alan. So, I want to talk about Snowman. And Snowman, to begin with, it's a static site generator for SparkQL endpoints, which means you give it some SparkQL queries, you give it a bit of HTML, some static files like CSS and JavaScript, and in the other end, you get a website. So I have promised a lot here that we in the next hour should build a page listing glaciers, creating individual pages for glaciers with images. We want to have an interactive map of glaciers, and we want to have some type of listing by country or something similar. There is an Etherpad in the Jitsi chat. It will also be on screen. The queries are already made. This is not so much an introduction to SparkQL as it is, this is Snowman, this is the concept. If you want to do something similar, you should have enough of the basics concepts to know where to go, what to do to get started. If you're in Jitsi, feel free to use the chat. It's really small on my side screen here, but I will try to have a look at it. Okay, so I'm going to start here in the terminal. and I just run snowman. It's a single binary, which I already have installed. I have a really big text here to help you, but let's see if it's helpful for me or not. Okay, so I just ran the snowman command without any arguments, and I see that there is a new command, generates a new project. So that's what I want to do. Snowman new, and I want to actually ask it for help. What can I send to this command? I can send a directory, that's all. So I'm gonna give it a directory, call it Glacier site, and it already says here, your project has been created in Glacier site. You can now run cd Glacier, so I move into the project, snowman build on snowman server. So I will do all of that. There we go. Let's just list the files in here. We got a couple of directories, free queries, static, templates, and then we got 2 files. But we will go into those in a moment. First, let's run those snowman commands. Snowman build. And this takes all of these files, do a bunch of stuff, and we should get a site in return. That's already finished. It took some SparkL queries, and now it's done. Let's see if something changed. So if I show here, we can see that there are now 2 new directories. There is something called .snowman, which is a hidden directory. It does a lot of things under the hood. You never need to look into that. It just holds information behind the sites, behind the scene. But we also got a site directory, and that essentially contains everything. So if I now run snowman server, that you start the HTTP server. I'm gonna copy this link into this particular browser, and we can see that it has already generated a web page here. Welcome to Snowman. You just generated your first web page with Snowman. Your endpoint is set to query.wikidata.org. That's really nice. And we can change it in snowman.yaml if we want. And it even shows us some data. It just shows us the first few triples in this Wikidata SparkL endpoint. We also get some getting started links and things like that. That's all in the Etherpad. Okay, but now we want to start to change this and actually make things with this. So I'm gonna jump back into the terminal, and I'm gonna turn off the server, and I'm gonna launch a development environment here. Just a few tabs. I'm gonna need to zoom into my. So I got an editor on one side, and I got 2 terminals. Do you need 2 terminals? Probably not. So I want to go into this snowman.yaml first. And the main thing this does is that it holds a bunch of metadata about your project. And the only thing you need to actually care about, especially if you're starting out, is the SparkL client section, which says this is the SparkL endpoint we want to use. And you can also give it some HTTP headers. And I happen to know that Lydia has been talking about the user agent policy. So we're going to go and update this. It's a temporary project, but we're still going to give it a name here. Let's call it Wikidata. We use days snowman live coding. And then a way to contact me. We already got a GitHub link here, so let's say my GitHub profile. There is probably an email there. Okay, so we don't really want to change that because it uses Wikidata by default. The next thing I want to show is views.yaml. This essentially connects all of your templates, HTML, with your queries. So we can see here, for example, that the index.html, which we were just looking at in the browser, it's connected to the query index.rq. And it has a template also called index.html. We also have this different view which should be rendered at static/index.html, and a template to go with it. In this case, it doesn't connect it to query because this just showcases how you can use Snowman without using an actual query on the other end. But if we would go back to the browser, then we would be able to go to /static, and we should have another page there. Static. Oh, I killed the server. Yeah. Let's run the server. Go back, reload, and here we say this is a static page. So we still want this index page, but we want it to display data about glaciers. So I have been cheating, as you can see in the Etherpad, because I have already made some queries. So I'm going to copy paste them into the queries directory of this Snowman project. We're going to paste. So we got one called glaciers, glaciers details, and countries. I'm going to delete this old one, index. I'm going to close this. We're not going to use the file browser anymore. Then I'm going to jump up to, yeah, I'm actually going to stay in views. And we're going to change, hey, let's make sure our index page is based on that glacier one instead. And I think it was plural. Okay. But now let's see what that index.html template looks like, because it shouldn't understand the contents of a query. So we got all of this introduction here. Let's remove that. Delete 10 down. And then, yeah, we can see it just expect a few SparkQL variables here. It expect one SPO. And we don't have that in our query. Let's have a look in our query what we actually have. So we move back up here and we connected it to the glaciers one. So let's see, this is what we're selecting. We're selecting QID, item label, latitude and longitude, a sample image, which means we're just taking one image if you're multiple, a random one, and country label, mountain range, and a little bit of that. I won't go too much into the query itself, but we can see here that we're selecting a glacier or subclass of glacier. We P18, the variable name says it, but it's an image. We do avoid glaciers with an end time. We just want the ones that still exist. But that's it. So instead of rendering random triplets, like first we want to take the item label, I think the QID, and the country label for the time being. So I'm going to jump back into the template and update it. So I'm going to say item. Let's start with the QID. The QID, then let's go with label. And did I say lastly, country? And that's it. We can see here that we have a loop. This essentially means that for every row that this SparkQL query returns, it should look for each of these variables. So if we go back here to the side, we can again run snowman build. And the trick I like to use is to say snowman build, and then when you're done, run also snowman server directly. It takes a little bit longer here to build. It still went really quick because it had a new query. Because the next time we are building something, we won't actually, it won't make any queries. Everything that will happen is that it will pick it up out of its own cache, so that every time you build, you won't need to wait for all of the queries to run, because some projects can have a lot of queries. Okay, so we should be able to reload this one, and I know I haven't updated that. We're getting there. Okay, so we got the QIDs for each glacier, the glacier label, and the country. Great. let's keep it going. Next up, we want to create pages for each of those glaciers. And I want to get back to the views one again. We're going to spend a lot of time in this one. So let's do it here under the main, where it's easy enough. And output, we want to do, where do we want to put it? We want to put it in /glaciers QID. And this is a little bit of a special thing you're going to see in a moment. And we want it to be connected to the same query as above. Let's yank that. And we also want to have the template of some kind. So let's go with glacier.html. We haven't created that one yet, but I want to explain what's going on here. Oops. So when you say something like this in your output, where we just have QID mentioned, what this means is that instead of giving all of the results from the query to the same view, just give it one row. And where the QID is in your result in each row, put that in our output path. So the first glacier, if that's Q10, it will output it at Q10, and this view will only have access to that one row. Okay, we need to create this glacier.html file. So we want to move back into templates. I want to copy what we got in our first file here. So I'm going to yank everything to the beginning. And let's create a new file. Glacier.html. Let's write that. Yes, I want to create that file. Paste it in here as a start. Okay, so we want a different title. We want an item label here. So I'm gonna make this simple for myself. We want to say item label. Then we don't need a table here anymore. Oh, this was a slow way of doing it. Yeah, I was committed. So let's see. We also want to display an image. And when you're requesting an image from the Wikidata Sparkle endpoint, it returns an actual URL to an image, to like the entire image. So that's what we're going to use. We don't have access to an alt text because the Wikimedia Commons Sparkle endpoint isn't accessible. So here we're going to reference an author Sparkle variable used. I assume I called it image. We're going to see if that's the case in just a moment. And because we're getting all of the image, I also want to add some basic CSS here, actually. Or just, no, we're not going to do it that way. Let's run this for the sake of demonstration. Hopefully we didn't do an error here. It's 50-50. Okay, so this is nice. We got a bunch of warnings here. It says that warning, writing to site/glaciers QID index for the second time. This means that we had a duplicate somewhere in the row, and it just warns that, hey, we wrote to this file twice. And this is something that happens every now and then when you work with Wikidata, because it got such a diverse data model that it's hard to really rule out all of the duplicates. Strategies for dealing with this exist, like, for example, what we did in the query for the image. We set sample, which picks a random one and avoids an extra duplicate. I'm going to leave this for the moment, but you can usually always get away with removing them if you just spend enough time on the query. Okay, but it built something, so that's nice. We can go back here, reload, And we should be able to just copy a QID, put it slash here, slash again, and see what it displayed. No, it shouldn't, because we said it should be rendered at slash glaciers slash QID. And there we go. And we can see already we got this massive image, because that's what the Sparkle endpoint returns, a file to the entire thing. So let's fix that. We can't have it like that. So there is another folder here in the root of a Snowman project called static, and this just holds static files, and we got a CSS file in here. And I just want to say for image, if we have an image block, give it the max width, the height will be automatically adjusted. Let's write that. And something really cool here with Snowman is that if I only change static files, why run everything again? Why build entire projects? We can say build static, and it just said, oh, it detected that something had changed in site/style.css, so it just updated that file and nothing else. But now I want to run Snowman server once again. But if I reload this, it should apply the CSS. Yes, much better. And I'm really zoomed in right now, so you should be able to see everything. Okay, that's amazing. Where are we in time? Okay, fine. We got a lot of pages. So let's see. What do we want to do next? We want to display some more information on those pages. And there are two ways to do this. Either in our main query, the glaciers query, we can return a lot more information, like we just did with the image. We can return external identifiers, whatever we want. But I want to demonstrate a different way of doing it, which necessarily isn't the best way to do it with Wikidata if you aren't running your own instance, but it illustrates a different approach. So this is called a parameterized query, which is essentially, this is Sparkle query, but it's not full. There is a section missing here where it just says wing dot wing. And this means that here you can inject something in through Snowman system. So if we go back into the template for Glacier, we can here say something like, we want to run some code. Let's say we want to create a variable called details. And then we want to make a query. And we want to point that to the file. I think it was called, let's see what it was called. Oops. It was called glacier details.rq. Nice. And we want to pass something to fill in that spot. It actually knows what we want to do. So we want to query glacier details.rq with or QID, so that that wing section we saw will be replaced with whatever we put here. But this will just return one row for us. So we actually want to say, I only want the first row. So we say index to get an index of all the rows, and then we say I want the first one by saying 0. So we can actually print details here by just saying details. Let's write this, give it all a run. This might take a little while to build. Ah, we got an error. I must have spelled something wrong, I guess. We couldn't find query glaciers details.rq. Could it be that it's singular? It appears, because it's going way much slower. We can't really see what's going on now. If you really need to debug what's going on with Snowman, is that you can pass verbose. So Snowman build flag verbose, and it will just print you issuing this query, building this page, and so on. But for this time, it just runs this really small query a lot of times. So that's why it's going slow. And it will only do this the first time or if we change the query. So for example, if you would now edit something on Wikidata and build Snowman again, the information wouldn't update until you clear the Snowman cache. And this essentially saves a lot of time when you're building, and it's really nice against SparkQL endpoints. We see the same warnings as before. Let's see. You can hear my hungry dog in the background. This was slower than expected. Let's see. How are we on time? Oh, fine on time still. I'm a little bit worried I promised too much here. Especially if it's going to be like this. But we should have run almost all queries when this is done, so I'm betting. Oh, it finished building. Okay, let's see. So let's switch back. And we can say it says we have a map here and an item. Which makes me curious. Is that actually what I expected? Let's see. Okay, so we want to work with these details. So we call say with because we want to access it. And that was not at all what I wanted. So let's see. Yeah, let's have a header here. And then do that's a little bit too easy. Sorry, computer. I want to do a paragraph and yeah, he's upset. He likes his food. And okay, we want that query returns area. It returns size, I think, and thickness. So let's make sure we have those in here. That should be fine, assuming that we have it, but we probably won't have it. So we must say if area, then we want to print we want to print area, else we want to print unknown. And finally, we want to end that if statement. And this should build fairly quickly. So let's start with just the area. Because you noticed last time it took a long time to build. Now it's already finished building. And that's because it knows the result of the queries already. Give it a reload. Area unknown. Let's go back to Glacier where we actually know the quite sure this Helix Glacier should have. And let's swap the QID. Yes, we got the area here. It doesn't say that it's in square meters, but that's fine for the time being. I'm proving a point. Okay, thank you very much. And thickness, thank you very much. So we can do one of those really quick rebuilds again. And this particular glacier happens to have all of them, so we know its area, we know its length, thickness, and everything is in square or meters, or square meters. It's not even time yet for who. Okay, great. And it of course did this for all of the Glacier pages. So what do we want to do next? I think we want to tackle the interactive map directly. And for this, we want to take the data we need, put it in a JSON file, then pull in some rendering library and put the data on the map. So let's do a good JSON file with the data we need. I'm going to call it map data.json. And let's see. We want to, assuming we work from the same query as before, we want to loop all of the glaciers, and we want to pick the label, the QID, and latitude and longitude. So let's make objects for all of those. So label, then we want to again access snowman information. So we do item label. Great. Let's, it's not called item, we call it QID. And I'm missing something. I'm missing citation marks around this, or quotes. Yeah. And then we want latitude and longitude. And there we do not need quotes. Okay. And we're gonna put a comma there then, and we get a lot of errors here because this is not JSON, but it's our template, so it doesn't really matter. We need to hook this up to view. So we want something very similar to this. I'm gonna copy this and just paste it here at the bottom. But we don't want to output it in index.html. We want to output it in map data.json, which was the same name as our template. Okay, that should do the trick. Let's see if we can rebuild this quickly. Oh, we got a crash. Let's see. We can't evaluate field item label in type. Oh, interesting. I know why. That's because I missed something. If we go back into the template, we never do an actual loop here. We're just trying to print the data. We should have asked the computer. We just want to range dot, and we need to spell things correctly as well. There we go. We got even more JSON errors, but it hardly matters. And that finished building it. Let's see if we can have a look at it as well. So it should be rendered at map data.json. And we get an error. And this is because when we did it this way, we're also getting a trailing comma at the end. And this is one thing that you will end up running into if you try to render JSON with Snowman, that trailing comma at the end. But there is an easier workaround for that, and it's to address it here in our template. Let's not have a comma there. Let's instead range with a counter, so we can range index. Then we can do item, and just gonna copy things over here. I'm gonna delete this all. Let's see. And item, that should be it. And then we should say, because we are renaming our main variable here, and Okay, so now when we have access to the index as well, what we can do here, which is really nice, is we can check if, oh, it even, not exactly what I wanted, if index, we can add a comma, which means that for the first item, when index is 0, because it's 0 indexing in Snowman, we won't print a comma, but for every order item. And if we then try to print a comma first, everything will have the comma in the right place. Let's see if we made an error.
I think you still want to remove the comma after lon, right?
I do. That's a really good point. Thank you. And I do not want to replace it with we still got an error. Undefined variable item. I wonder if I need to explicitly clarify this. Let's give that a try before I check my notes. Yes, that's how I do it. Okay, then we get back to browser, reload the JSON, and we do no longer get an error here. So we got it. That's perfect. Now we want to pull in a JavaScript library to deal with the map rendering. We're not going to build our own thing here. So this is in the layout, template/layouts of Snowman, where you essentially can define various types of layouts and blocks. So we have a block here for the title, where you can inject it in the child template, or content here, where we're currently been editing. But I want to introduce some map dependencies here. And in that Etherpad, I have put some code, which I hope no one is editing, because this is my notebook. Or I hope you add notes, but not edit the code I have here. I'm just gonna paste that in there so that we got access to that. Then we wanna create a view where we can actually render or map. And I'm gonna reuse this static one that we got for free when we started. So I'm gonna go to map/index.html. And that page on its own, because we have the data already in the JSON file, this is actually already done. We don't need a query. So let's jump back into, let's rename this as well. Hold up, map. Yes. Okay, great. We can remove this content. We can move in here, say map. We can create just the empty element for that. And we can start bootstrapping some code here for the map. So let's do that. We want to fetch that file. And let's see. I think that all looks correct. We do want to end this script tag. And we're essentially just looping information, adding a tile set from the street map, and that should be it. Okay, finish building. Let's see if we had a bug in there. So there should now be a page at /map. We got a page. Do we have any glaciers as well? We do not. Do we have any console errors? Yes. It looks like we got a 404 response from that, and that makes complete sense because it should look like that. And I also don't want that starting coordinates. That's much better. Let's rebuild it and give it a reload. That's it. Here we got them. If I click them, we should get a label. Yes, we do have a label. It just happens to be QID here. So this should be helix that we looked at before. And of course, this is not a design class. This is how you work with Snowman. In the best of world, we would create a layout with a full page screen. We would replace the icon and it would look really lovely, but it's not. And if you wanted to go to the Wikidata reuse days to learn web design, you are missing form, I guess. So this is what we're going to stick with for the time being. That's really nice. And we still have 20 minutes. So let's see. We also want a country page. That's a really interesting topic. So let's go back to the main. So I want to be able to have like a page for France and then just lists the glaciers in France. So let's think about that one. We do want a new template. So we essentially need two things here. We need one that just lists the countries, and we need one that is a page for the countries with all the glaciers. I think we're going to start with it later. And for the sake of getting an overview of things, let's start in this views one. In general, if you end up looking at a new Snowman project for all kinds, like Gov directory is a good example, and you just want to know what's going on in this project, head into the views file and you get this overview of, okay, it got an index.html with this query, with this template. Okay, it has a page for each glacier. You can get a really good sense of a Snowman project by looking in this file. Okay, so we want countries. So we want to define output. We want things to be outputted in, I'm gonna try to put it in the same type of structure as before. Countries / and then do the QID. And you don't need to use the QID in your URLs. They just happens to be really nice in my opinion, because they are always URL safe and unique. But in the best of worlds, you would have something human readable. So in this case, we want a page for France rendering here. And so there are two ways to go about this. Either we write a query for returning just glaciers from France, or we write one of those queries where we pass in a parameter like, hey, use France. Or in our case, because I'm a little bit lazy, we are gonna reuse the original glaciers.rq file and then just put an if statement in the loop that's gonna list the glacier. If this says France here, let's render it. It will also be really nice because Snowman would already know about the query and everyone will be happy. So let's do that. Query glaciers.rq, and we need a new template here. Template. Oh, we can't call that query. We need to say that. Country.html. And we should spell that because otherwise we're gonna make an error later on. Okay, that's great. Let's create a template. Let's copy the contents of this one. And country.rq, and as long as we match the spelling rather than spell correctly, we're fine. Okay, so let's see here. We do not have an image in my country query. We do have no, we do not have an item label because I call it country label. Did I call it RQ? Ah, nice catch. Yes, we need to fix that. I'm gonna save it to begin with, and I'm gonna HTML. Nice catch. This is why we have a chat. Okay, we're not gonna do the details here. Can remove all of this section. Doing it the slow way again. So let's see. Let's start with this and see if everything renders correctly. Builds are really fast. Yes, everything seemed to work. These do look a little bit odd, but I'm running a development version of Snowman, so I hope it's that. And I think we should have Norway in here, so Q20. Countries, interesting. Let's see what's going on. So if you need to like what's really going on with my part, all of this is just outputting static files. So if I do list of files here, we can see that we have this site directory, which is essentially everything we build ends up in that. So we can move into that and just see what's going on. So I can see we do have a countries folder, which looks nice. And then if oh, we have a bunch of QIs here. Is it just that we don't have Norway? These are very long QIDs as well. You know what? I know what it is. We are using the wrong query. If we move back up here into queries, I don't want to use Glacier's queries for the country pages. I want to use the countries.rq, which makes a lot of sense. So let's go in and fix that. We just need to point it to somewhere else. Countries.rq, write that, cd back out, and run snowman, build a snowman server again. There we go. And it took a little bit longer there to render because this was a new query Snowman hadn't looked at yet. There we go. And we get a page here now for Norway. That makes a lot of sense. But we still want to list glaciers there, right? So let's move back into that template. And do something similar to before, where we use the query inline here. So let's say glaciers, and we want to query. And this might look like you're doing a lot of queries, but when Snowman has done a query once, it will not do it again. It just keeps it in the cache. So glaciers.rq, and that doesn't take a parameter, so that's done like that. And then we want to loop that variable, glaciers, and let's put this in a list. Like that. Let's fill it out. And there we go. So we want to do something similar to before here. We want to, let's make it link direct. So we want a slash, we want it to go to root, glaciers. I'm gonna check the clock. Got a lot of time. I didn't overpromise at all. And we want to say QID. And whenever you loop, you might note that we are back to using a dot. So whenever you create a context around a variable, like you work in a special area like defining something from a layout, like define content or title, or you range something, your current context is always dot followed by whatever variables you have access to. Okay, so that's it. Let's also render the label. And this, of course, has a problem. We are still asking for all of the glaciers, not just the ones from Norway. So there we go. Let's give this a try. Something happened, at least nothing crashed. Okay, so now we're listing all the glaciers. That's nice, but not what we wanted. So as I mentioned, either we could have a glaciers.arc query here, which takes Norway as a QID here. But in our case, we're gonna make it simpler. We're gonna say the current country. We're gonna need to make this within parameters because we are writing code. Current country is equal to country label. There we go. And now we can say if dot item dot country label, which is in the context of the current glacier, is equal to, we've got an equal function here, to current country. Then render this, and we need an end here. So for Norway, we should at least get a few glaciers. Let's see. Finish building, reload. Yes, we just got a couple of Norwegian glaciers. And we also got the links working here. The images are of course slow because we're just taking the URL we get. We can visit all of them like this. That's really nice. So with this done, we could list the countries on a page. Let's see. But I much rather actually go back to the map and make it so that we can click on the things. So we have this bind pop-up here, and I think this should just take HTML. So if I do something like an HTML or a JavaScript template string and say something like that, that should work. Yes, we only have 10 minutes left. That's perfect. Let's see, we gave it a reload, but we need to go back to the map. Let's see, let's scroll in. We got it undefined. We renamed something wrong. Item lat QID, it's probably not item label then. I think I just call it label because it's not the name of the SparkL variable here, it's the name that we're getting from the JSON that we render. So let's give that a rebuild, and it's probably finished building already. Let's give it a zoom in. That is just a QID, so let's pick a different one. In Glacier, we got a link. It says undefined here. And the link is not correct either. But this is what happens when you're lazy. Okay, but if we didn't call it QID in the JSON, what did we call it? Let's save this and move back up one. We called it item just. Oh. Then let's call it item. Item.item, that's really nice. There we go. Let's give it a reload. Let's use the Swedish one again. He likes glacier. And we got the links working in the map as well. That's really nice. Svartisen in Norway. Lovely. So I think I've done most of what I promised. In less than an hour. We should clean this up as well, so that you get a nice page when I publish this for the sake of demonstration. And it's quick because we got really quick builds. Let's change this area here, the content area. Glaciers, let's do the same in the page title. And finally, let's make this a link here. Glaciers / snowman variable .qid and item label. That should be it. Let's change this item label here to mountain range label, which I think is a thing. Let's see if it is. There we go. Let's give it a reload. That's much better. Then we can click and get to the glaciers from the start page as well. And with that, I think we're gonna round off. I'm gonna publish this on Codeberg. The code is all gonna end up in the Etherpad as well, so you will be able to find the link here. And I just quickly, before I let the VMD staff that are hosting this evening to take off for the day, I'm just gonna show off the Snowman manual. The link is in the Etherpad. This is the big documentation where you want to go if you wanna learn stuff about Snowman commands, about template syntax, about all of its function. Like you can do math inside of Snowman templates. You can do replace with regex. You can fetch file using HTTP. You got things for typing, and it also got a bunch of guides for how do you set up CLE auto completion. How do you work with multiple environments, like have a development and a production environment, and all kinds of that. And of course, you can also, if you're missing something here, or if you find a bug in Snowman, you can use GitHub to contribute. And with that, I should leave over to our hosts. Thank you very much.
Wow, thank you, Alvin. Thank you so much for the wonderful session. It was really awesome. I think we have about 5 minutes on the clock left. Anybody has any questions, comments, response, please feel free to raise your hand or unmute yourself, or if you want, you can type the question in the chat. So Alvin can respond to it.
And I will have a look at the Etherpad the coming days as well. So if you have a question, not today, but tomorrow, drop it in the Etherpad and I will get back to you.
Okay, there's a question in the chat. Alvin, I'm not going to read out. You can answer.
Yes. So can Snowman be included in an auto framework? So not currently, but there is on the roadmap, not for the upcoming release, but the release after that, to be able to make Snowman embeddable in auto programs. You can still combine it with a different static site aggregator like Hugo, because both of them output files, so you can just chain their commands essentially. I have seen that because, for example, something Snowman does not do is rendering Markdown, but Hugo does. But embedding it in the software itself is something that's coming up in not the upcoming version, but the version after that.
Thank you. I've just copied the question into the Etherpad. So
thank you very much.
All right. I think yeah, thank you for the answer. Yeah, if there are no further questions, I think We have had a very nice evening today in Germany, and of course in wherever part of the world you are. We had a very nice sessions with everyone. So if you have further questions, please feel free to write them in the Etherpad. So of course Albin will be able to address that later on. So thank you, Albin, for your wonderful session. Thank you everyone for your questions and participation. Do join us tomorrow starting at 1700 UTC for more fun and interactive sessions at the Wikidata Data Reuse Days 2025. Thank you so much everyone, and see you tomorrow.